Here's a quick little walkthrough of graphing tangent and cotangent, so section 4.5, day 2. If we make a table for the tangent function, first of all, we remember that tangent is sine over cosine. And so we can take some of the ideas of the unit circle, which you can see here on the side, as well as some of the values for tangent that we know off of quadrant 1 or reference angles, so like the hand trick to fill out the table. At angle 0, sine is the second coordinate, so it's 0 divided by cosine. 0 divided by 1, well, that's 0. At pi over 4, that's 45 degrees, and the tangent of 45 degrees is 1. That's something we should have memorized. And then at pi over 2, which is 90 degrees, the coordinates tell me that this is 1 divided by 0, which is undefined. We can't divide by 0. If we go one more, because this will help create the pattern for tangent, 3 pi over 4 is in the second quadrant. Its reference angle is still pi over 4, so the value is going to be 1, but in this quadrant, tangent is negative, so negative 1 fills my table. At pi, sine divided by cosine is 0 divided by negative 1, so that's 0, and thus you can see our pattern. The pattern is going to repeat since this is a periodic function. So we graph this. We have 0, 1, undefined, negative 1, 0, 1, undefined, negative 1, 0, if it kept going 1, undefined. And so we're able to kind of create both sides, the positive and negative x values from negative 2 to 2 of the parent function for tangent. A couple of things that I want you to note about tangent, not that it's going uphill, that's the wrong way to think about it, but these pieces, each little section separated by vertical asymptotes has increasing values. So tangent is increasing on each little domain, and it begins at 0 since sine begins at 0. That'll help us identify the tangent graph. Now, some tangent facts, just kind of like we've been doing for all the rest of them. The period of the parent function for tangent is only pi. Normally, sine, cosine, cosecant, and secant, their period is 2 pi. But if you notice, the next time we have a 0 with an increasing value is at pi. So the period of the tangent function is just pi, which then changes the formulas that we use to find period and frequency, which we'll talk about later. Amplitude, it's not technically an amplitude, which is why I have these air quotes around it. But if you look at the y coordinates here, surrounding the 0 of tangent, that is my amplitude. If we multiply by a 3 in front of the tangent function, essentially changing the amplitude to 3, this value wouldn't go to 1, it would go to 3. And that'll help us vertically stretch our graphs. The domain is any number except for the first vertical asymptote, pi over 2, and the distance from the first vertical asymptote to the second vertical asymptote, which in this case is pi distance. So pi over 2 plus pi repetitions. The range is all real numbers, though. It's unbounded on the bottom and unbounded on the top. The equation for the vertical asymptotes, and this is the part that people ask me a lot of questions about. The first value here in the vertical asymptotes is the first place a vertical asymptote shows up. I like to use on the positive x-axis because it's pretty easy to find. The next number, this pi, is how far that first asymptote is to the second asymptote. To go from pi over 2 to 3 pi over 2, you'd have to add 2 pi over 2, which reduces just to pi. So the first vertical asymptote, the distance to the next vertical asymptote, times k. Zeros, the formula for the zeros is kind of the same. You look for the first place that a 0 shows up, which for this function is at 0. And then you measure the distance to the next one, which again, just kind of like the vertical asymptotes, is pi. It usually lines up for tangent and cotangent that the zeros in the vertical asymptotes, the plus number is the period. Usually. I would still formulate it and count it on your graph just to be sure. Some more things about tangent that we need to know in regards to how it relates to sine and cosine. Again, because of this relationship here, tangent is always going to have an undefined moment, a vertical asymptote, at the zeros of cosine. Because if my denominator is 0, then this is an undefined fraction. So when cosine has a 0, tangent is going to have a vertical asymptote or a hole in the graph. Tangent also has zeros at the zeros of sine, because when the numerator is 0, then the whole fraction is 0. So those are some interesting facts, maybe to help you identify the tangent function. Now we can do all the same things for the cotangent functions, remembering that cotangent is the inverse of tangent, or the reciprocal, sorry, not the inverse, the reciprocal of tangent, which means we can just use the reciprocal fraction, cosine divided by sine. Using the same ideas around the unit circle of cosine and sine, we know that the cotangent of 0 is 1 divided by 0, which is undefined. Reciprocal of 1 is 1. If you look at the top, cosine divided by sine is 0. And in a second quadrant, cotangent, just like tangent, will be negative. And again, we have our pattern. So this function actually starts with not a 0, but a vertical asymptote on 0. The pattern goes high, middle, low, vertical asymptote, high, middle, low, vertical asymptote, over and over again, repeating that period, because it's a periodic function. So some of the facts about cotangent: the period, again, just like tangent, is just pi, because it takes just pi distance along the x-axis for my function to start repeating, for it to complete one period. The amplitude, again, air quotes amplitude, the y-coordinates that we can plot is 1. And if the number a value, the vertical transformation, is more than 1 or less than 1, then this number will change how high or low that you graph that coordinate. So it's amplitude with air quotes. The domain is all real numbers except for the vertical asymptotes, which appear at 0, and then a repetition of every pi after that. The range is, again, all real numbers because it's unbounded at the top and the bottom. The vertical asymptotes, okay, we talked through how to find this a second ago. Remember, the first number is where the first vertical asymptote shows up, and the second number with the k next to it is the distance from that vertical asymptote to the next vertical asymptote, which again is a pi distance away. And the zeros of this function occur the first time you see the graph crossing the x-axis, which is at pi over 2. And the second number is the distance from that 0 to the next 0, which in this case is pi distance, repeated over and over again since it's a periodic function. A couple things to note about cotangent. We already talked about it beginning with a vertical asymptote instead of a 0. Additionally, this is a decreasing period, so it should go high, middle, low. Tangent went low, middle, high. Those are just some things to help you graph it / remember which kind of function you're dealing with. And if we compare cotangent to sine and cosine, again, because of this relationship that cotangent is cosine over sine, cotangent is going to have vertical asymptotes when sine, the denominator, is 0, because it's undefined. And cotangent is going to be 0 when cosine is 0, since the numerator is 0. And then last but not least, we have all of our transformations for cotangent and tangent. A is still the amplitude, but air quotes amplitude because it's not really what it is, but it works the same, so we can kind of think of that. The period is affected by B. However, this is super important. Most of the time for sine, cosine, secant, and cosecant, we've been using 2 pi divided by B as the formula for period. That was because the original period was 2 pi. For tangent, the original period is pi. So the formula for period is pi divided by B. C and D are the same. They affect the starting position, so phase shifting starting at left and right, or the displacement, which is the center line. Now, if we look through a problem, this is straight off the homework, and if you weren't in class, I actually changed the homework instructions to graph the function for numbers 5 through 12 on the interval negative 2 pi to 2 pi. I think it says to graph 2 periods of the function. I'm going to ask you to go negative 2 pi to 2 pi on your test, so we're going to practice that way. So, describing the graph of the function in terms of the basic trigonometric function. So, obviously, this is a transformation of tangent. And because there's a b value of 2, this is a horizontal shrink by 1/2, which means we should take the normal tangent graph. I wish you could see my hands right now, but I'm on a recording. And we're going to shrink it horizontally, which means my hands are coming closer together horizontally, so it should coil up. If it was a spring, it would get a tighter spring as opposed to a wider spring. The period for this function is pi over 2, so every pi over 2, we should repeat the tangent wave. The x increment, no, it doesn't ask you for these two parts, but to graph the function, you need these two. So you should always be finding the period in the x increment when you're asked to graph. The x increment is the period divided by 4, so pi over 2 divided by 4, which is the same as saying pi over 2 times 1/4, because fractions are division. Slash, you have that phrase, keep, change, flip. So we kept it, we changed it, we flipped it. So we know our x increment is pi over 8. I know mine is already graphed, so you can't see me physically graphing it. But what I've done here, let me highlight this in a different color. I have taken pi over 8, which means that there are 1, 2, 3, 4, 5, 6, 7, 8 tick marks between 0 and pi. Each one of those tick marks is an important value that I can plot. For tangent, it's either going to be a 0, an amplitude value, a vertical asymptote, or this lower amplitude value. Over and over again, that pattern is going to repeat since it's a periodic function. Okay? So we do that. We line up, or we set up our x increments correctly so that we can just follow the patterns. Tangent starts at a 0, so I plot 0. I also know tangent is an increasing function, so I go up to the amplitude, air quotes amplitude. The next is a vertical asymptote. The very next tick mark should be a lower amplitude, then a 0, then a higher amplitude, and then a vertical asymptote. We repeat that pattern over and over again on every tick mark that we created, since we know the x increment is pi over 8. One thing I do want us to notice is that we did check on the period here. We said the period, or the time it takes for this tangent function to repeat, should be pi over 2. So if I start here, it starts repeating here. That's 1 pi over 8, 2 pi's over 8, 3 pi over 8, 4 pi over 8. But 4 pi over 8 reduces to pi over 2, so that checks out. Our period is correct on our drawing. Now we just make sure we finish drawing it on both sides of the x-axis from negative 2 pi to 2 pi, repeating that pattern for every tick mark that you put in your x increment. It may be more or less than me. Pi over 8 just happens to be the x increment for this graph. The last thing that this problem asks for, and there is a formula to finding the vertical asymptotes, but I think it's easier from a graph to be able to see the vertical asymptotes. So the formula that you want to make for your vertical asymptotes, and we kind of talked about this already, is that vertical asymptote always is x equals. It's a vertical line. Can't be a y, it has to be an x. It's a Vux line. The first number you put in this formula is the first vertical asymptote that shows up on your graph. Our first vertical asymptote is here. That's 1, 2 pi's over 8. Well, 2 pi over 8 is pi over 4. We just reduced that fraction. And then you're going to add the distance from the first to the second times k. So I'm going to count, literally, that's what these little green marks are. 1, 2, 3, 4. 4 tick marks to get to the next vertical asymptote. So that's 4 pi's over 8. But 4 pi over 8 reduces to pi over 2. So our formula for the vertical asymptotes for this graph is x equal to pi over 4 plus pi over 2k. The first vertical asymptote, and then the distance from first to second.